Hi, in this video, we'll be learning about how we can make pixels with color. So we've seen how images are made up of pixels. Pixels are the tiny little squares, each of which have their own color, that come together in a grid such that when viewed from a distance, the image looks smooth and it looks like it has curves and lines. But it's all made up of those tiny little pixels that are tiny squares with one constant color. So to make an image digital, to represent an image with numbers, an image can really just be represented as a grid of values, where each value encodes the color at that position in the image. It encodes the color for that pixel. So we've seen the very simple system of just 1 bit per pixel. 0 means black and 1 means white. And this is great when we want to make simple black and white images. But what about color? The RGB encoding scheme allows us to encode colors as numeric data. And the way it does this is it defines the amount of red, green, and blue light in a pixel. This is where RGB comes from, red, green, blue. And the idea here is that any color can be created by combining red, green, and blue light at varying intensities. The way this works is each pixel gets 3 values. 1 value for red, 1 value for green, and 1 value for blue. And putting those 3 values together makes a color. So if we have 0 for every channel, then we have no light. We have a black pixel. If we have some mix in between, say we had 156 red, 54 green, and 255 blue, that gives us purple. And if we have them all the way up, if we have 255 for every single channel, that's how we get white. We max out each color to its max intensity, and we get a white pixel. So each color channel gets its own value in the range from 0 to 255. This is the minimum and maximum value for any pixel channel, RGB. Let's explore this in the editor. So here we're back in our bit interpreter, and now we're interpreting bits as color pixels as opposed to black and white pixels. We can still go back to interpreting as black and white if we want, but this is going to completely change the scheme. Right now, these first 8 bits encode the entire picture because we only have 1 bit per color. So I can change this first one to a 1, and it'll end up turning white. But if we want to interpret as color, it takes a lot more bits to represent a single color. So here, these first 24 bits are encoding black. This next, every channel is on. We have all 1s for red, all 1s for green, all 1s for blue, so that's going to be white. Here only red is on, so that's going to be red. And here only green is on, so this is going to be green. If we ever want to figure out how to make a color that we don't know how to make using bits, we can use this color picker over here. So just dragging this around, you can see what string of bits maps to what color. We can drag this up and down to get various colors and drag this around to get various brightnesses. So let's try to finish out our image by trying to create every color we can possibly make by turning channels all the way on. So we've made red and green. How can we make blue? Well, blue is going to have the red and green channels turned all the way off and the blue channel turned all the way on, 255, the maximum value for blue. So we want a 0 for red, a 0 for green, and a 255 for blue, so that's 8 1s. Awesome, so we made blue. We can also switch from binary to hexadecimal, and this is going to make typing a lot easier for us. So here, instead of 8 bits per color channel, we have 2 hexadecimal digits per color channel. So these first 2 encode red, second 2 encode green, last 2 encode blue. So that's why this pixel is red, this pixel is green, this pixel is blue. So we've tried combining red and green. What if we combine green and blue? What color is that going to be? We'll turn red off, green on, blue on. So that made cyan, and that makes sense. Here we see right in between green and blue, we have cyan. All right, now it's your turn.